Welcome back, guys. Today we'll be doing part 3, implicit differentiation. Let's get started. Let 4x squared plus 3xy squared plus 7x plus 3y equals 0. Use implicit differentiation to show that the derivative is equal to negative 8x plus 3y squared plus 7 all over 3 open bracket 1 plus 2xy. Now this question is coming from CAPE Unit 2 2019 and 2015 past paper. It was repeated. Now let me go ahead and rewrite the function 4x squared plus 3xy squared plus 7x plus 3y equal 0. Now when we're differentiating implicitly, just remember, as stated in the previous videos that you saw, if you're seeing a y, we have to put dy dx beside it when differentiating. So let's go ahead and differentiate this function. So 4x squared, we multiply the 4 times the 2, so that gives me 8, and subtract 1 from the power x, so that's why I have a 1 here. Differentiating 3xy squared, we have to use product rule because it's two functions. So I'll assign 1 to be u, which will be 3x, and y squared to be v. So once you have two functions side by side, that's product rule. Differentiating this, I have to differentiate the u, so that will give me 3, because x becomes 1, so 1 times 3 is 3. Differentiating the y squared now, we will get 2y, so differentiate y squared, carry the 2 in front, then subtract 1 from the power, so it's 2y, and then we attach dy dx. So whenever you see y, you have to attach dy dx. So bring on the 2 and then subtract 1, so some persons will have y to the 1. That's fine if you want to write that, but you have to have dy dx. So now product rule, we're going to attach the u and the v prime together and u prime and v together. So multiplying 3x times 2y dy dx, that will give me 3x times 2y dy over dx, then plus multiply u prime times v, so I'll have plus 3y squared, and I will close my bracket. Now differentiating 7x, that will give us 7, and differentiating 3y, that will give me 3, but now you have to put dy dx. So differentiating the y becomes 1, so 3 times 1, that's 3, but dy dx. And we're going to have equals 0. Now we are going to simplify what's in the bracket, because 3x times 2y can be 6xy dy dx. So the 3 times 2, that gives me 6. Everything else, I will make it remain as is. So let me go ahead and rewrite everything else. Nothing else can be done but just grouping. So what I need to do next is to carry 8x, 3y squared, and plus 7 over the equal sign, because these three terms don't have dy dx. So the sign will change. Everything else remains on the left hand side. So we have 6xy dy over dx plus 3 times dy over dx. Now I'm going to have my equal sign. On the right hand side, we're going to have negative 8x, because the positive 8x carried over the equal sign, along with 3y squared becoming negative 3y squared minus 7. So all three items, the sign changes once you carry it over the equal sign. Now, I will be factoring out the dy dx, that's common, so I'll be factoring it out. So I'll have dy over dx, and then what is left within the bracket, I will have the 6xy plus 3. So let me go ahead and write 6xy plus 3. Now, factoring out the minus sign on the right hand side, so that's what I'm doing now. So if I factor out the minus sign, everything within will become positive. So as you can see, 8x plus 3y squared plus 7. Now I'm going to divide both sides by 6xy plus 3. Both sides will be divided to get rid of it on the left hand side. So all I have on my left is dy over dx. So divide both sides by 6xy plus 3. That cancels on the left. So all that is remaining is just dy dx on my left, and on my right I will have minus 8x plus 3y squared plus 7 all over 6xy plus 3. But we're not finished, because look at what we have here, the dy over dx. In the denominator, it is not looking like what I should have. So let me rewrite what I have right here. This is what I have so far, minus 8x plus 3y squared plus 7 all over 6xy plus 3. And here we need to factor out the 3 because we need to get it as how we're having it in the question they're asking us to show. So it has to look exactly like above. So I have to, in the denominator, factor out the 3. Nothing will be done with the numerator. It is okay as it is. I'm seeing the same numerator as in the question. And the denominator, I need to factor out this 3. So factoring out the 3, where I have 6xy, 3 into 6 goes 2 times, so I will have 2xy, and 3 into 3 goes 1 time, so I'll just have plus 1. Just to rearrange so that it looks just the same. So in the denominator, 2xy plus 1 is the same thing as writing it as 1 plus 2xy. So the denominator will just have 3 open bracket 1 plus 2xy. And that's it. Now we have proven it. Now the next example, we're going to use implicit differentiation to find dy over dx for the function e to the 2xy minus sine xy equal 4. Now to differentiate e to the 2xy, we have to use chain rule. Just a reminder, when you're differentiating an exponential, you differentiate the power, so we'll get f prime x e to the fx. So when we're differentiating this function, we have to differentiate the power, but the power is in a product form. We have 2x and we have y. So it's not just differentiating and getting a value or a variable, but we have to differentiate using product rule, because we have the function 2x and we have the function y, which is side by side. So as you can see, I'm letting u to be 2x. So differentiating this, we will arrive at 2. Then we differentiate y, we will arrive at 1, but dy dx has to be attached to it. So we differentiate y, we get 1, then we attach dy over dx. Now it's the same thing as rewriting it as the derivative of y is dy over dx. Now we're going to apply product rule. So we have 2x times dy dx and then 2 times y. So applying the derivative for this e to the 2xy, we have to apply product rule to the power. So we will have 2x times dy dx, that's u times the v prime, plus Then we have 2 times y, that's 2y, close the bracket. So all of that represents the derivative of the power. Then you rewrite the exponential e to the 2xy. So we differentiate this by applying product rule to the power. That's what you're seeing in front of the exponential. And remember, we differentiate 2x to get 2, differentiate y to get dy dx, which is the same as 1 dy dx. Then we cross multiply. That's how we get what's in front of the exponential. Now, let's look at the sign. We have to apply chain rule to this, where I differentiate sign to get cos. So I'll have minus, then cos. Rewrite my xy, so I just differentiate sign to get cos, rewrite my xy. Then I'm going to differentiate the inside. So chain rule, you differentiate the outside to get cos. And now we're going to differentiate the inside, which is two functions, x and y. So I have to apply product rule. So differentiating x, we will get 1. Differentiating y, we'll get 1, but we have to attach dy over dx. So in other words, this is the same as dy over dx. So to differentiate within, applying product rule, multiply x times dy dx, I will have x dy over dx, that's multiplying u times v prime, plus u prime times v, that's 1 times y, that's y. Let's do this one more time. So we're going to apply chain rule. We differentiate the outside to get cos xy. Then we differentiate the inside. So we have x and y. We differentiate x to get 1 and y to be dy over dx, which is the same as 1 dy over dx. Then we multiply u times v, then u prime times v. So that's product rule. Now on the right hand side, the derivative of 4 is 0. The next step, I'm going to clear the brackets, so multiplying each of what is within the bracket by e to the 2xy. So e to the 2xy times 2x dy dx gives us 2x e to the 2xy times dy over dx. Now multiplying the exponential times 2y, we have 2y e to the 2xy minus cos xy times x dy dx, and then cos xy times y. So I'll have minus x cos xy dy over dx, and then minus cos xy times y, that's minus y cos xy, and then it's equals 0. Now the dy dx will be left on the left. So I'm going to go ahead and write the 2x e to the 2xy dy dx first. So I'm going to go ahead and write that. So I have 2x e to the 2xy dy over dx. Now this other one has dy dx, so I'm going to attach it together with the next dy dx. So I have minus x cos xy dy over dx. So it's times dy over dx equal, and the ones that don't have dy dx, we carry over to the right. So 2y e to the 2xy, that will become negative 2y e to the 2xy. The next function without dy dx, it will be minus y cos xy, so it will become positive y cos xy. Now on my left, I am going to factor out dy over dx. So we are factoring out dy over dx, that's common. So factor out dy over dx. And what am I left with? 2x e to the 2xy minus x cos xy equal to, nothing will be done here as yet. We'll leave it as it is. Then we're going to divide both sides by 2x e to the 2xy minus x cos xy. So both sides will be divided by this so that we can get rid of this expression that's on the left. All of this that's on the left, we're going to get rid of it. So to get rid of it, we have to divide both the left hand side and the right hand side by 2x e to the 2xy minus x cos xy. Now, on the left, these two cancel, so what is remaining is dy over dx on my left, and it's equal to all of what you're seeing on my right. Now, this is a derivative, dy over dx, but we can go further. So the next activity that I'm going to do is simplifying this. Let's get started. Now, here we can factor out in the numerator minus y. We can factor out minus y. So I'm going to factor out the negative sign along with the y in the numerator. So this minus sign and this letter y. So I'll be factoring it out. And that means the sign will not be plus anymore, but will be minus. So factoring out minus y, I'll be left with 2 e to the 2xy. And the plus will become a minus sign, so it becomes minus cos xy. So I will factor out the variable x in the denominator, so these two will be factored out. So what is left when it's factored out? I'm left with 2e to the 2xy minus, so the factoring out, minus cos xy. Now you should be seeing that the both brackets are the same, so now I can cancel them. So what do I have? I have dy over dx is equal to minus y over x. And that's it. That's the derivative. Thanks for watching. Don't forget to like and subscribe to my channel. Have a great day.